Electromagnetic clutches. The majority of electromagnetic clutches use a single plate friction surface to engage the input and output members of a clutch. Although there are multiple disc and tooth designs, all function in a similar manner. Electromagnetic clutches can be found in almost any application that requires the transfer of rotary motion. The key components of the clutch are output, which can be directly connected or have a pulley or timing belt like the example shown here, armature, rotor, and field coil. Electromagnetic clutches operate via an electric actuation, but transmit torque mechanically. When voltage or current is applied to the clutch, the coil becomes an electromagnet and produces magnetic lines of flux. This flux is then transferred through the small air gap between the field and the rotor. The rotor portion of the clutch becomes magnetized and sets up a magnetic loop that pulls the armature against the rotor. When the clutch is fully engaged, torque transfer is 100% efficient as there is no relative slip. When current or voltage is removed from the clutch, springs hold the armature away from the rotor surface, creating a small air gap. In most mobile or outdoor applications, friction material is not used. However, in most industrial applications, friction material is used to help slow down the wear in a clutch or brake. The friction material is flush with the steel poles. The single friction plate design allows for a very fast response in high cycle applications. The key components to the clutch are the hub or pulley, armature, rotor, and field. A ball bearing is mounted under the hub or pulley for support. Another ball bearing is located between the rotor and the field. It supports the weight of the field during rotation, allowing the field assembly to remain stationary. Newer model clutches are one-piece designs that are extremely easy to install. The smallest models include an integral key. Older style general-purpose clutches are two-piece construction, so the shafting going through the clutch has to be able to support both halves of the clutch. All general-purpose clutches have either a built-in pulley or a universal mount flange. The universal mount flange option is the most flexible because you can simply change the pulley or sprocket diameter to get the operating speed required. When utilizing a standard clutch with different pulleys, you reduce inventory cost and increase operating speed flexibility. Clutches operate electrically but transmit torque mechanically. When current is applied to the clutch coil, it becomes an electromagnet and produces magnetic lines of flux. In multiple pole clutches, the magnetic attraction points are multiplied by the number of flux paths created. Smaller general-purpose clutches use a double flux construction, but higher torque general-purpose clutches use a triple flux design. When magnetic flux is created in the field coil, it goes into the rotor, which has a number of slots. On the corresponding armature, similar slots are made, which forces the flux to travel in a north-south pattern, looping across the armature and rotor face. These multiple points of contact increase the torque output of the clutch, reducing weight and size. The magnetized rotor and armature attract each other. The clutch slips for a very short time on initial engagement. The time depends upon the speed and the inertia being accelerated. The torque is transmitted from the rotor to the armature and into the leaf springs driving the hub or pulley. When the clutch is fully engaged, there is no slippage, and the torque transfer is 100% efficient. All general-purpose clutches use leaf springs to transmit the torque. The springs need to run in tension, not compression. So clutches are either built to run clockwise or counterclockwise. When the current or voltage is removed from the clutch, the armature is pulled away and held in place by the leaf springs, creating a small air gap. In all general-purpose clutches, friction material is not used, and contact is steel on steel. General-purpose clutches allow the operator to engage rotation only when needed. This increases the life of the driven component. Also, since it is not running all the time, horsepower is not being wasted, which results in fuel savings.